Hello, the Math Dog here. This video is on the introduction to slope. I have it listed as a grade 7 topic. That's when it's supposed to be introduced in Common Core, but from experience I found that students as late as 9th grade in Algebra 1 do not know how to calculate slope. So it really depends on how hard previous teachers worked on slope with students, because it does take some practice to kind of get it straight so that you do it consistently right. So technically it's supposed to be grade 7, but this could actually be valuable to a 9th or 10th grader in Algebra 1, or frankly even geometry. So this video is not to be shared or reproduced without the written consent of the creator, me, the Math Dog. So what is slope? Slope measures the steepness of a line or line segment. We want a larger number to be associated with a steeper slope. So for example, this is a positive slope. We measure slope generally, we're just going to say for now we go from left to right. So I have two runners. I have line segment A, line segment B. A is steeper than B, so we want line A to have a larger number associated with it for the slope than line B. So we actually assign numbers to slope. It's a measure of steepness. So again, line A has a steeper slope than line B. It has a larger number associated with its slope. As we move from left to right, both line A and B rise. They both have a positive slope. So we consider this a positive slope. As I move from left to right, both lines are going up. So if I move this far horizontally, I go up this far vertically. If I go the same distance horizontally on B, I don't go up as far vertically as I did in line A. So that's a little right triangle here. More on that in a moment. So again, what is slope? Slope measures steepness of a line or line segment. We want a larger number to be associated with a steeper slope. Now we have what we want to be negative slopes, because as A, in the case of line segment A, the runner is falling as he or she moves from left to right. But line B is steeper in a negative direction. So let's just make up a number here. This slope could be, say, -20. This slope could be -5. I want the absolute value. So the absolute value of -20 is 20. Absolute value -5. The two verticals mean absolute value is 5. So this has in some ways you could say this is a smaller number, because on a number line -20 is to the left of -5. However, the absolute value of -20 is 20. The absolute value of -5 is 5. So we say that line B is steeper, but it's steeper in a negative direction. So line B has a steeper slope than line A. It falls more rapidly as we move from left to right than line A. So if I go, say, 1 unit down for A, for B, let's do it this way. I want to do that again. So I'm actually going to go on top here. I can do that. If I go 1 unit over for A, notice I don't go as far down as if I go 1 unit over for B. So we say that line B has a steeper, it's a more negative slope than line A. Again, both lines are falling as we move from left to right, so both lines have a negative slope. So if you have a line or line segment, just by visual inspection, you should be able to figure out if it's a positive or negative slope. So what is slope? So the way we measure slope, and right now the triangle means change in, it's pronounced delta. So delta means change in right now. So here is some line or line segment. Okay, slope we say is the change in y. Here's the xy axis. It's the change in y over the change in x. So we can draw a right triangle under the line or line segment, and we measure the change in y with respect to x. We also call it rise to run. As I've stated down here, slope is the change in y over change in x, which we can abbreviate with delta y over delta x. It's also called and often referred to as the rise to run. And it's the delta vertical Could also be called the change in vertical over to change in horizontal. So again, delta means change in. So this line should have a positive slope. So let's now calculate slope. The first way, I'm going to show two methods. The first method is you draw a right triangle under the line. You could either do it above or below. So I'm going to draw a right triangle below. So starting at one of the points I know is on the line, I move horizontally until I get right under the second point, and then I draw a vertical line segment. Okay, now I count the units. And you're counting spaces, not lines. So this is 1 space, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So that is a horizontal change of 13, and this is a right triangle. I can represent it with a little square there to show it's a right triangle. And now going up from here, because I counted to this point 13 spaces, 1, 2, 3, 4, 5, 6, 7, 8, 9. So we say the change, the slope, or change in y to change in x, or rise to run, or change in vertical or change in horizontal is 9/13. So 9/13 means for every 13 units horizontally, we go up 9. Now you could also have started, actually you can go the other way to do this. Sometimes you actually have to. So we could have started this way, and I go, okay, so starting at this point 5,4, how far am I going horizontally? Well, I'm going there, so I'm directly above the point. So we're moving to the left, so that's a negative. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So that's negative 13 in the horizontal, and then I go down from this point right here. 1, 2, 3, 4, 5, 6, 7, 8, 9. So that's negative 9. So using that way of counting, we get delta y over delta x is negative 9 over negative 13, but a negative divided by negative is a positive, so we still end up with a positive slope. So you can do this either way. Method 2 is make a slope table. So what I do is I take the ordered pairs that I have, and I've given you two ordered pairs. I've given you negative 8, negative 5. And I've given you 5, 4. So now you either, doesn't matter which point you put on top. You're going to subtract, you take the difference. You're going to subtract delta y over delta x. You could also go up, but you have to go up in the same direction, and we'll do that over here. So I have negative 8, negative 5. You only need to do it one way, but I'm going to demonstrate you can actually do it both ways here. Alright, so then I'm going to do it the second way in a moment, to go this way. But you have to have both differences or subtractions in the same direction. So my delta y, change in y over change in x here, is going to be negative 5 minus 4 over negative 8 minus 5. But that's negative 9 over negative 13, which is 9/13. The other way, I'm going to go delta y over delta x, and again delta y over delta x is the same as rise to run, change in vertical over change in horizontal. I'm going to go 4 minus negative 5 over 5 minus negative 8. So you're taking the difference here. So this is also going to be 9/13. So in general, the formula for slope, if you have, let's draw a sketch here. So let's suppose we have a line segment. We have 2 points on the line, and in general, this is the general formula, a general formula for slope. So we have 1 point, we call it x sub 1, y sub 1. So this is called a subscript. So we say x, this is x sub 1, this is y sub 1. And I'm going to call this other point x sub 2, y sub 2. So slope, one way of looking at this, again, we could draw a diagram. or draw a triangle under these 2 points. So this is supposed to be a right triangle. So this length here is going to be x sub 2 minus x sub 1. And this distance here is going to be y sub, this length here is y sub 2 minus y sub 1. So delta y over delta x in general is y sub 2 minus y sub 1 over x sub 2 minus x sub 1. But you could also go the other way, just to let you know. You could go y sub 1 minus y sub 2 over x sub 1 minus x sub 2. You just have to make sure you're subtracting in the same direction. So in general, a slope table might look like this. This is x sub 1, y sub 1, x sub 2, y sub 2. If I subtract this way, I get this formula, y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Or if I went down the other way, I have to be consistent going down in both things here. That would be y sub 1 minus y sub 2 or x sub 1 minus x sub 2. So this is the general formula for slope, which is actually what we just did with these 2 examples here. Okay, so let's do another problem here. So method 1, draw a right triangle under the line. So I'm going to do that. So I have negative 8, 4, and 2, 2. This line is falling, so off the bat, you just can look at it. You know you've got a negative slope going on here. So I'm going to go down 2. So I'm now lined up with this point, and I go over here. So using this method, the right triangle I just drew, I have negative 2 down vertically. I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 this way. So the slope there from the diagram, delta y, delta x, is changing. Y is negative 2, changing x is 10. That can be reduced though to negative 1/5. So notice this, these are proportional triangles, or these are similar triangles, because I could have actually also done this. I could have gone down 1, 2, 3, 4, 5. So negative 1 over 5. So notice these 2 triangles are similar. That is, they're the same shape, they're just not the same size. So you can actually take any 2 points on the line that you can identify to calculate the slope, because a straight line will always have similar triangles. Okay, so that's method 1, but you could also go on top and you could go this way. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 this way. Okay, and down 2 this way. So you're still going to get negative 2/10 for your slope, which reduces to negative 1/5. Now method 2 is using a slope table. So we have the coordinates negative 8, 4 and 2, 2. So the slope, let's go this way here. Again, you got to subtract the same direction or you're going to mess it up here. You've got to go the same way. So this is going to be 4 minus 2 over negative 8 minus 2, which is 2 over negative 10, which again reduces to negative 1/5. You could have gone the other way though. So delta y over delta x is going to be 2 minus 4, change in y, over change in x, which is 2 minus negative 8, which gives you again negative 2/10, which again is negative 1/5. Alright, stop the video. Calculate the slope of the line below by drawing a right triangle above or below the line. So stop, look at it, calculate the slope, and then start the video to see if you did it correctly. Okay, let's look to see what you did here. So I got to identify the coordinates of the points first. That's negative 8. That's negative 8, positive 3. This is 1, negative 1. Okay. Actually, for this method, you don't need to identify the coordinates. I just did. So I'm going to go down. I'll start here. I'm going to go from here to where I'm horizontally lined up with this point. Then I'm going to go over this way. So to do this, I went 1, 2, 3, 4 down. So that's -4. So I went down 4. So I'm following, always moving vertically and horizontally to calculate slope. So now I'm going horizontally from here, 1, 2, 3, 4, 5, 6, 7, 8, 9. So my slope is -4/9 because it's the vertical change over horizontal change. You could have actually started at this point here and worked this way. You could have gone 1, 2, 3, 4 vertically. You put you here, now you're horizontally lined up with this point, then you go 1, 2, 3, 4, 5, 6, 7, 8. Let's count that again. Did I make a mistake? 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so that's -9. Well, that's going to be 4 over -9 for the slope, but that's the same as -4/9. So either way, here you're going up 4 and you're going left, which is -9. So either way, as long as you draw a right triangle there, will get you the correct slope using this method. Okay, stop the video again. You can use any one of these you could use any 2 of these 3 points to calculate the slope. You could draw a right triangle. You don't have to do both. Just stop the video and calculate the slope. Okay, let's see what you did. So let's use this right triangle first, these 2 points, to make a right triangle. So I'm going to move over 2 and up . So I'm going this way. I'm going over 2, then I'm going up this way. 1, 2, 3, 4, 5. So slope is delta y over delta x, so it's 5/2. It's not 2/5. It's a change in vertical over change in horizontal. Now you could have come back 2. That'd be -2 and down -5, but -5 over -2 is also 5/2. Now just to demonstrate, I could have used, say, these 2 points here and here. And let's do that just for demonstration purposes. So let's do, okay, so here if I start here to get under this point here, I go there, then I'm going to go up. And that's horizontally 4 units. And that's up 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Up 10. So this is delta y over delta x is 10/4, but 10/4, you can divide 2 into both those, is 5/2. You could also go, could have done this just to point this out. I could have gone from this point to this point. That would be sorry about the dogs. So I could go over this way and then come up, went too far. Come up this way right here. Okay, and let's count the units there. So I'm going this way. That's 1, 2, 3, 4, 5, 6. Horizontally, then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Let's count that again. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Oh, that should be 6 over. Let me do this again. I'm sorry, because let's highlight this. So I'm going from here to here. Went too far there. Then I'm going up here. So that's actually 1, 2, 3, 4, 5, 6 horizontally. Then vertically, I'm going 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Well, 15, 6, I can divide 3 into both of those. And that gives me 5 halves again. So any way you slice it or dice it, you're going to get a slope of 5 halves. Okay, this is another problem that I want you to do. I want you to stop the video, calculate the coordinates of these, figure out the coordinates of these 2 points, put them in the slope table, and calculate the correct slope. So again, stop the video, do the work, then restart the video to see if your answer agrees with mine. Okay, so let's take a look at this. So this point here is 3, 5. And this point here is 9 over 3 up, so that has coordinates 9, 3. Again, this is the x direction, this is the y direction. So my x coordinates, it doesn't matter which one I put on top. I'm going to put 3, 5 on top. Then I'm going to put 9, 3 on the bottom. And I'm going to go down for both of these. So delta y over delta x is going to be 5 minus 3 over 3 minus 9, which is 2 over negative 6, but that reduces to negative 1/3. Notice that, again, if you drew a right triangle under there, you're going down 2 units, 1, 2, and then you're going over, so that's negative 2 down, and then that's 1, 2, 3, 4, 5, 6, so that's change in y, negative 2 over 6 is negative 1/3. Notice you could have used a smaller right triangle to calculate the slope. The line goes through that point, and it goes through that point. Well, that's negative 1 over 3 also. So again, you have a stair step type thing going on with slope, because actually that's how you measure. You actually, when they build stairs, they talk about the rise to run, the tread and the risers. So because it does matter how steep you make a staircase, but you can just keep going down, cascading down, negative 1 over 3, negative 1 over 3, negative 1 over 3. You could do that forever, because a line has a constant rate of change, and this line's constant rate of change is negative 1/3. The rate of change is the change in vertical over change in horizontal, or rise to run, or delta y over delta x. Okay, so I want you again to stop the video. This is a different line here. Calculate the slope of the line shown by first completing the slope table. So choose any 2 points that are on the line. I've given you several, but choose any 2 points, complete the slope table, then calculate the slope. And be sure your final answer is in lowest terms or simplest terms. Okay, let's take a look at this. So I'm going to choose these 2 points here. So the coordinate of this point is negative 4, 4. Coordinate of this point is negative 3, 8. Doesn't matter which one you put in the slope table first. I'm going to put negative 3, 8, negative 4, 4. So you could go down for both change in y over change in x, or you could go up. I'm going to go down. I'm actually going to go up this time. So I'm going to go this way. So my delta y over delta x is 4 minus 8 over negative 4 minus 3. So notice this should be a positive slope when we're done. So if you got something else, you know you made a mistake. So 4 minus 8 is negative 4. Negative 4 minus 3 is negative 4 plus 3, which is negative 1. Well, negative divided by negative is a positive, so that is a slope of 4 to 1, or 4. You can see that right here. So that's 1 over 4 up. Notice again, this is a staircase. We're going 1 over 4 up forever. 1 over 4 up. 1 over 4 up. So the ratio of rise to run, or ratio of change in y to change of x, is 4 to 1. That's why it's often helpful to write, instead of writing 4, it's often helpful to write the slope as 4 to 1 to remind yourself that it's a ratio. Now, it's very important that you take change in y over change in x. A common mistake for beginners is to take delta x over delta y, but that would give a slope of 1/4, and that's, you want, again, a steeper line to have a larger number associated with it. If you reverse these, you're going to get the exact opposite effect. So now let's look at two special cases, horizontal and vertical lines. So recall slope is change in y over change in x, which is rise to run, which is change in vertical over change in horizontal. Well, here I have a horizontal line, so it's easy to see what's going on here by making a slope table. So this is -8, -3. And so many students, again, if you forget what to do, just draw a horizontal line and put some coordinates on it, and this will make this answer very easy to see. So I've got -8, -3, I got -1, -3. You could use any 2 points on the line, so I'm going to put -8, -3 in, and I'm put -1, -3 in. So change in y over change in x is going to be, let's go down this time. That's -3 minus -3 over -8 minus -1. Well, that's -3, that becomes plus. That's 0 over -8, that becomes plus. So -8 plus 1 is -7. But 0 over anything, it's, again, if it's like a piece of pie, if you had to somehow had a pie that had 7, well, you could do it, had 7 equal pieces, you have 0 pieces, so this is just 0. So the slope is 0. So horizontal lines have a slope always of 0. Well, now let's look at a vertical line. So again, slope is delta y over delta x, rise to run, change in vertical over change in horizontal. So let's take any 2 points on this vertical line. Well, this is -7, -2. This is -7, 8. So if I make a slope table, -7, 8, -7, -2, I'm going to go this way this time. So delta y over delta x is equal to 8 minus -2 over -7 minus -7. Well, that's plus, so 8 plus 2 is 10. This is plus, so -7 plus 7 is 0. Well, you can't have division by 0. So the slope of a vertical line is always undefined. We say it's undefined or has no slope. So again, if you forget, a lot of beginning students get these two mixed up, but if you take the time to draw a simple vertical line and just put some coordinates on it, you can figure out what the answer should be. So this again is undefined. Vertical lines have an undefined slope, horizontal lines have a slope of 0. Alright, special cases, horizontal and vertical lines. In general, the slope of a horizontal line is 0, and the slope of a vertical line is undefined. So now I've given you a line, I've given you coordinates of these 2 points. I want you to stop the video and identify the mistake in my calculations. So I have filled out a slope table here. I've calculated the slope to be 7/2. I want you to look at this and identify my mistake. Then start the video and I will go over this. Alright, let's take a look at what I've done here. So I have -8, -4, I have -1, -2. I put this here, I put this here. There's nothing wrong with that. It looks like I went, well, let's see what I did. I went -1 minus -8. There's my mistake right there. Over -2 minus -4. My mistake is I took delta x over delta y. That's not what you do. You take delta y over delta x. So if I'm to go down, the proper calculation would have been -2 minus -4 over -1 minus -8. Well, that's a plus, so -2 plus 4 is 2. -1 plus 8 is 7, so the correct slope is 2/7, not 7/2. By the way, the slope of 7/2 would look like something like this. That's 2 over 1, 2, 3, 4, 5, 6, 7. Notice how much steeper of a line that would be than what if you calculated 2 sevenths. That's what 7/2 would look like. Much steeper. Alright, same thing here. I want you to look at the slope table and figure out the mistake I made. Stop the video. Okay, let's see if you figured out what I did wrong here. So I took 6 minus -5. I took delta y over 5 minus -7. The problem is, notice I did not subtract in the same direction here. That is, you cannot do that. It has to be either down, or it has to, for both, or it has to be up. So delta y, the proper calculation here would be delta y equals delta x. I'm sorry, delta y over delta x equals 6 minus -5 over, excuse me, I should be going down this way. -7 minus 5. Well, that's a double negative. 6 plus 5 is 11. -7 minus 5 is -11 is -12. So my proper answer, the correct answer, is -11/12, not 11/12. And you should see this. If you see this, this line is falling from left to right. So you could just visually, I gave you the line here, you could visually inspect this. You're not always going to be able to do that. You should see that that is the wrong answer. Okay, stop the video. Identify the mistakes in my calculations looking at line A and line B. And then we'll go over this. Alright, let's take a look at this. So line A, I have a vertical line, coordinates 5, 8, 5, -4. So what did I do? I took 5 minus 5. So I took delta x over delta y. That's 12. So that's, it should be, well, I have 0. This is delta y, sorry. That should be delta y over delta x. So I got a slope of 0. That's the slope for a horizontal line. A vertical line should be taking delta y over delta x. Let's make a slope table here. This is for A. So I have 5, 8, and I have 5, -4. So I should have taken 8, let's go this way. I should have taken 8 minus -4 over 5 minus 5. Well, that's 8 plus 4, that's 12 over 0. This is undefined. Slope here of A is not 0, it is undefined. So let's take a look at line B. So I have -8, -2, -1, -2. Again, I took the change in x over change in y. That is wrong. It's delta y. It's change in y over change in x. So I have a horizontal line. I said it's undefined. That's wrong. I should have made a slope table. And let's take the point -8, -2, -1, -2, delta y over delta x. Let's go up this time both ways. So that's going to be -2 minus -2 over -1 minus -8. Well, double negative makes positive. -2 plus 2 is 0. That's -1 plus 8 is 7, which equals 0. Horizontal lines have a slope of 0. Vertical lines always have a slope that is undefined. And this concludes the video.